Assalamu alaikum students. You are watching my channel Mathematics with Upword. So this is question number 4. Let's do the question number 4. Question number 4. This is find the upper bound and lower bounds of the average speed of these measurements. Of these measured times and distances. So what you do, give your answer to three significant figures. So in last we want the answer should be on three significant figures. So what part A says is the distance is traveled by 6.4 centimeter in 1.2 seconds. Both values to two significant figure. So now we have to find the upper bound and lower bound of the average speed. So for finding the upper bound of average speed, so let's first write the formula for upper bound of the average speed. So it's basically distance divided by time. This is the average speed, but the upper bound of the average speed is upper bound of the distance divided by upper bound of the distance divided by lower bound of the time. So for finding the average speed, so this is for upper bound UB, average speed. So distance should be in upper bound. This represents the upper bound, and the time will be the lower bound, because when you divide with the time with the lower value, so our value will increase. This is the division rule. So if the time is greater than 1, let's see the upper bound of a distance. So we first of all, for finding the upper bound of a distance, is you have to find the accuracy first. So now here you can see it says both values to two significant figures. So the accuracy for this will become What is the two significant figure of a 6.4? Is this is the first significant figure 6, this is the second. So the accuracy will become 0.1 centimeter. So the error will become 0.1 divided by 2. Divided by 2, you will get 0.05. So this is the error. So now this error also belongs to the seconds because it says both values, no? So this is the one is the first significant figure for the seconds, and two is the second significant figure for the seconds. So distance now distance is 6.4. You will add the error term and divide with the time, which is 1.2 seconds, and subtract 0.05, because this value go up, this value go down. This is the lower upper bound for the distance. This is the lower bound. So now when you calculate this, what you will get when you calculate, let's use the calculator. So now we have 6.4. So now we have 6.4 plus 0.05 whole divided by 1.2 minus 0.05. So this is the answer. The answer is the 5.608. 5 approximately the answer 5.608, but this is the approximation. So in a question, it says we have to find the answer should be in a 3 significant figures. So this is also in a centimeter per second, because there is the unit of the speed here, no? So what we will get here is 5.61 centimeter per second. So this is the average speed. So now for finding the lower bound AVG, this is the speed. What we will do is 6.4 minus 0.05, subtract the error term, means key less term, make this short. So and add 1.2 plus 0.05. So this is the upper bound, the upper bound for distance. So this is upper bound for the t, it's for the time. So when you calculate this value, how much we will get, let's see. So we have 6.4, subtract 0.05 and divide with 1.2 plus 0.05. So this you will get. So the answer is 5.08 centimeter per second. So this is I think so this is the exact answer. 5.08 centimeter per second. This is the lower bound of the speed. So I think that's it for this question. So now further we will solve the question number 5. Let's do this. Question 5. In a question number 5, it says calculate to three significant figures. The minimum width of the triangle of the rectangle with these dimensions. So the part A is about the area. What it says in an area 210 centimeters square to three significant figures, and the length is 17.8 centimeter to the nearest millimeter. So what the question says in here to calculate to three significant figures. So the answer should be on a three significant figure. The minimum width of a rectangle with these dimensions. So now what we have to find is the minimum width. Okay. Now the area is given and the length is given. So first of all, what the formula for the area or area of the rectangle? So area of the rectangle is length into width. So this is some kind of this. So this is length. This is length and this is width. But sometimes flip, but that's okay, because I think these both are same if you see something some other angle, no? So now what we have to find is the minimum width, no? So minimum width will become so lower bound of an area and upper bound of a length. So the value should go down and value should go up. So because we want in a denominator the larger value, because it divides with the complete, and the answer should be minimum. So this is some kind of a but now one thing should be clear is that you have to find the area, no? This says area is equals to 210 centimeter cube. Oh, sorry, the it's not should be a cube but square. Let me correct it. Now it's correct. So first of all, it says area to three significant figures. So this is first significant figure, this is second, this is third. So now we will find the accuracy for the area, no? So the accuracy for the area is equals to three significant figures. So this is the 1 centimeter square. So when you divide this 1 centimeter you will get 1 by 2 and it's 0.5. So simple, we got 0.5. This is our term for the area. So now it says the length is to nearest millimeter. So now you have to find the 17.8 centimeter to nearest millimeter. So you have to find the nearest millimeter. No? So the length is given in a centimeter. So now what we'll do is if I say one uh, 1 centimeter is equals to 10. But why I should do this now? But let's convert this into a millimeter now. So see 1 centimeter is equals to 10 millimeter. So now what we'll do is just multiply 17.8. I get the product of a 7.8 with the 10. When you multiply with the 10, 17.8 into 10, you will get 178. This is in a millimeter. So now nearest millimeter. So the accuracy is nearest millimeter. So accuracy for what? It's for length. For length is nearest millimeter. It's 1 millimeter. So divide this by 2. So the error for accuracy. So 1 millimeter divided by 2, you will get to 0.50. So now the error is 0.5. So upper length for upper bound for the length is 178 plus 0.5. You will get 178.5. So now this is in a millimeter, but I want the answer should be in a centimeter. So what I will do is 178.5 divided by 10, because of 1 centimeter is equals to 10 millimeter. So what we will get is the 17.85. This is our 7 centimeter. So now this is the upper bound of a length, but now we have changed the unit into centimeters. So let me correct it because it's not properly written. So this will become 17.85. So this is in 7 centimeters. So now we will see here the lower bound of an area. So our area is 210. If I say here, see, you can see it's 210. So lower bound for this is 0.5. So divided by upper bound of a length. So now upper bound of a length is 17.85. So because I have here just calculated the upper bound length. So now I don't have to add something other thing. No? So now what we will get is 210 point subtract 0.5. So and divided by 17.85. So we will get 11.736. So our answer should be three significant figures. So this is first significant figure, this is second, this is third. So the answer should be 11.70 centimeter. Why? Because the unit for this is centimeter square and unit for this is centimeter. So centimeter is cancelled. Now you will get just 1 centimeter, which is minimum length. So now our answer is minimum. So I hope you have understood it. This is the width. So minimum width we have found for the rectangle. So that's it. Lafis. Like, share, and subscribe.